prescribe or taking minutes. Goes on. Otherwise, they're on an MD5 hash, and the highest one wins. All right. Jabber, minutes. No path to fame and riches.
This sucks. This is not connecting. Oh, there we go.
You look like a minute man.
2 minutes.
Thanks, Mike. This shall not be forgotten here.
What's under Ralph?
All right.
Okay.
Anyone jabber? Okay, let me check with Mitenko crowd whether stuff's working.
So you are you make it ready for jabber?
You jabber?
That was a volunteer. Did you notice that?
Yes.
That was just a volunteer.
And since this is a beer working group, so you can be as cynical as you want.
Beer working, I didn't know, sorry.
All right. That works. That works. All right. Oh, I should do this first too. Like the way every click like goes right through that mic. Can you hear me? You guys hear me okay?
Yes.
Welcome. Is it time? Yeah, it is. 2 after. Shoot, that was 2 minutes ago. You were scared. All right, welcome. Second day of the beer group. I want to point out that we asked for 2.5 hours. They gave us 2 hours and another hour slot. That's a total of 3, and somehow we managed to fill it. So there are some open issues I did want to talk about. Things come up here and there. I think discussion worked pretty well yesterday. We have 4 presentations today. Be quick about them if you can and leave the room for a lot of questions, because discussion is the big reason I think that we're all in the same room together. So beer working group, welcome. Here we are. Note well? Noted? Excellent. So first on the agenda for today is beer resilience. And our slides right there. And who's going to be presenting this? Mike, you doing this? Oh, excellent. Nice shirt. This should work. Let's give it a shot.
Good morning, everyone. I'm Chuan Xiong from ZTE. My presentation today is Resilience for Beer Networks. Oh, sorry.
Oh, let me try again. Try now.
Okay. Let's do the quick overview. The draft discussed the resilience use cases for beer-specific networks. We explored the requirements of the beer resilience. Finally, we propose solutions for beer, including the protection mechanisms and detection methods. And for the requirements, the listed requirements must be supported with any type of transport layer over which beer layer can be realized. The beer protection type may be defined and configured from a centralized controller or management network, including beer end-to-end protection and link or load protection. And it is required to support the failure detection and the notification mechanisms. And finally, it is required to support the fast protection switching for the beer packets within the limited time. And so we will add more requirements in the future work if is required. We provide these 3 use cases for beer resilience. The use case 1 is end-to-end 1+1 protection. In this scenario, the multi-cast traffic must be sent across the network through the disjoint paths, and the BFERs lead to receive the flows transiting from one of the paths. For example, as the figure shows, there are two paths from source to destination, and the path one is from BFIR2A to B2C to BFER1 and BFER2, and the path 2 is from BFIR to F2E 2D to BFER1 and BFER2. If one of them fails, then the destination node, like the BFER1 and BFER2, will receive their flows from one or from another path. And for use case 2, this is an end-to-end one-to-one protection. The BFIR will send multicast flows from the working path and switch onto the backup path when failures occur. And for example, the working path is from BFIR2A to B2C to the destination, and the backup path is from BFIR to F2E 2D and to BFER1 and BFER2. If the working path fails, the traffic will switch on to the backup path. And the next use case is the beer local protection. The backup link should be provided, and the traffic is switched onto the pre-established backup path to get packets to the downstream node when the beer link fails. For example, the protected beer link is from BFIR to BFRA, and the backup link is pre-established link from BFIR to BFRA. For example, from the BFIR to BFRF and to BFRA. So we listed all the resilience solutions for beer, including the use cases, protection mechanisms, detection methods, and failure processing. For example, end-to-end 1+1 protection. The protection mechanism is to send traffic across two disjoint end-to-end paths when the failure occurs. The destination node will receive the flows transiting from the no failure path, and the detection method here is the beer P2MP BFD, and this method has been provided in the beer BFD draft, which proposed by Fang Wei Hu and the Greg Muskie. And for the end-to-end one-to-one protection, the protection mechanism is protect from backup end-to-end paths, and when the failure occurs, it will switch onto the backup end-to-end paths, and the detection method is the beer P2MP active tail BFD, and the method will be provided in the last version in the beer BFD draft. And the last one, the beer local protection, is to protect from backup beer link. And the methods for the protection mechanism is to set pre-established backup link. For example, the possible solution is the P2P or P2MP R3PT or segment routing tuner, or the TILFA methods. The details of these methods will be provided in the future discussion. And when the failure occurs, the traffic will switch onto the backup link. So for this draft, the last step is to do further research directions, like the more resilience use cases and related detection methods. So comments and the discussion are very welcome. Thank you.
It's like scratching nails across the keyboard. No comments, no questions, nobody to the mic? Anyone wake up yet? In the wrong room. That's even better. Yeah. Wait, you were taking minutes.
Rashad Rahman from Cisco. Actually, right before I was taking a look at the BFD draft from, I think, Han and Greg, and I sent a question to the mailing list. I think it would be good if that BFD draft, because my questions would have been answered if I had read that draft. And the BFD draft just says, hey, we do multi-point and no active tail. And that's pretty much it. You go, good, but what do you do with that?
Yeah.
And the answer is this.
Yes.
Thank you.
Rashad, thank you for your comments and thank you for Greg Mirsky, ZTE. Yes, thank you. I apologize. We'll try better. Yes, so it's a very good point. We'll provide the reference from BFD draft to this draft because this draft already provides this reference. So basically, yes, I understand it will be useful to have it as a demonstration of the use case. We'll do it.
So I imagine the intent is adoption. Who's read the doc? Who feels this is work should be adopted by the working group? We're half and half. I didn't give. Oh, you want a hand count? Who read the draft? Hand count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And adopt. 1, 2, 3, 4, 5. All right. Thank you very much.
Thank you.
I will take that to the list. Actually, following up on that comment would be great. I understand the use case was an important part of it, but I was hoping to talk about the machinery for these things and not just what we accomplished with them. So it's kind of hard to have a discussion in the room without that exposed machinery. Of course, we'll get there. Let's take it to the list. Next. It's the BFD draft. I think it was on. You empowered? No, it doesn't work. I have to say boot for me.
Okay, so this is the BFD draft. So I'm Fan Wei from ZTE. Okay, thanks. So this is the change from version 0 and version 01. So we remove the definition of BIER-OM packet format and refer it from BIER-PIN because the BIER-OM packet format has been defined in BIER-PIN. So we just only refer it and define the BIER-OM BFD field. Okay. The second, we remove the one hop bootstrap part and only keep multi-hop bootstrap because the BIER is an overlay technology and it is more likely that the BFR are connected by tunnels. So we think the one hop bootstrap is not necessary. So we only keep the multi-hop bootstrap in this document. And the third, we correct some reference, some draft that has been published, so we correct some reference and force that we reach and the security and the acknowledgement part. So thanks. So now we are bringing review the BFD principle. So BFD is based on BFD multi-point. and we use debug model. So there is no three-way handshake. So there is a comment from Rahamers just now that the BFD multi-pointer only defines the unidirection and unidirection from the head to tail. So I think the word unicast should be correct as unidirection. So I just reply the mail in the mail list. So BFER uses source address and my descriptor to demultiplex BFD session. So the source address for the MPS network, we think that the source address should be BFIR ID and beer MPS label. For the non-MPS network, we think the source address is BFIR ID and BIFT ID. So next. So here is the BFD encapsulation. The BFD encapsulation uses the beer OM packet format defined in beer pin. So the message type fed must be set to beer BFD. So this value will be assigned by Anna. And the BFD control packet immediately from the beer OM header. So question from
Stephen, I have a question about this. So, I mean, logically, it makes sense that you have the OAM header before the BFD header, but since BFD has to be, processed by line cards and so on, and should be as efficient as possible, I wonder if it would be better to not use the OAM header. The only thing the OAM header gives you, it seems to be like there's an OAM type and some some reserved bits, but it doesn't really add any value.
But don't we have the
Name.
problem? It's me. All right, Tony P. Juniper. But isn't it the problem that we may go out of band? How do you nail the BFD on the beer path?
Greg Mirsky, ZT. Their goal of OEM shim is similar to what well-known UDP port in IP UDP encapsulation gives. So it's demultiplexing protocols. We propose to use what's known as ACH, BFD control message format, so without IP UDP overhead. And thus, that's why there is the reference to use BFIR ID as identifier of the source. So it's a trade-off, yes. One can use, for example, as IP packet and follow, for example, 5884 recommendation, so to use the destination IP address as loopback range, and then use BFD well-known port as the destination port number to demultiplex. But if we don't have this UDP header, then we need somehow to identify that this is a BFD packet.
Right.
So that's we use this OEM shim layer, and we have BFD type as so that we know how to parse.
So Tony P, one is an important need, and then stick. I do not remember whether the encapsulation forces you the source BFR ID when you encaps. If not, then it's better be marked that this is the requirement. Otherwise, you cannot demux.
No, but again, since packet already beer packet already has BFR ID.
That's my observation. I don't know whether it's mandatory to set it. I simply don't remember.
Okay. Okay, it's a good point.
The important check.
Okay.
The other one, because you have the next protocol in the packet, you know it OAM. I see no problem. People will put it on line cards. And the out of path is a problem.
No, but again, putting on the line cards, it's not a problem. People put on the line cards 5884 with looking for well-known UDP port in IP UDP encapsulation. So in terms of processing, there is not much different because you need to demultiplex it anyway.
Okay, Steve?
Yeah, okay, I agree. It's very minor, but basically with this proposal, you have the beer next header says it's OAM, then you have 4 bytes, and then you have, and in those 4 bytes it says it's a BFD packet, and then you have the BFD header. And I don't see why you need those 4 bytes in between there, because in the beer header, you could say that next protocol is BFD.
Yes, you can have, I agree, yes, there are not one way to slice the bread. We can have then multiple points saying, okay, next protocol is BFD, next protocol is echo request, next protocol is echo reply. It's just, you know, where you do demultiplexing, whether you do demultiplexing on the protocol field or you do demultiplexing on OEM.
We do not have that many protocol bits.
Yeah,
To
so
start to go wild. I already had, interesting requests. Every overlay thinks they're special. They want the protocol field on here, not the architecture. And this is a valid discussion. But if we run out of the protocol thing, will we do it OEM? Yes. Okay.
Rashad Rahman from Cisco. And I don't think we have an ether type whatever for BFD, right? We use the well-known UDP port from what I remember, right? There's no protocol. I mean, there's, how would you would need to define something new.
in IP, okay. We have in the tunnels, 2 encapsulations used. So it's either IP UDP encapsulation or it's ACH. ACH doesn't have header, so thus you have only BFD control message, which needs to be identified because otherwise you don't know what your payload is. Okay, so what Stig proposes is, well, it's a valid approach to have it in the next protocol, but there is a concern that we'll run out of namespace.
And the other thing I want to say back to Tony, so I'm fine. I mean, I think I understand now why you're doing that. It's fine. Tony, you were mentioning that if we don't use that OM header, we'll go out of band. I don't think that's true.
Well, if you send the BFD message some other way and not in a beer packet.
No, it is a beer. It is a beer packet. Just, I mean, I think what Stig was proposing, beer packet, no AM, okay, header.
Misunderstanding. I thought you wanted to send it just BFD plain.
Yeah, but anyway, I think we're all agreeing that the OM, okay, header is fine, I think.
No, okay. We don't have to agree here right now, but at least explaining why we're doing it, because it's for demultiplexing and saving the space in next protocol.
So, yeah, we might see it a little differently, but I understand what your idea is, Charlie.
Yeah, we don't want you to agree here. We want you to disagree, but in verbose terms.
Well, we did, and we don't anymore, so.
Okay.
Next slide.
Yeah, next slide. So the bootstrap for BFD session, we use the multi-hop bootstrapping. So we use beer OM pin to bootstrap the BFD session. Next. So next step. So the comments that we should consider active tail solution. So we will add this solution in the next version. So just a quick comments. So and any more comments about this draft?
Rashad Rahman, Cisco. So I haven't looked at beer ping in a long while. I just know that when we did LSP ping with BFD, there were some issues of which Greg is aware of. So just make sure that the same lack of clarity which happened in some cases in LSP ping does not happen with beer ping.
Yes. Yes, thank you. Again, there will be some other alternatives to Bootstrap the session. The one thing is that problem with using ping to Bootstrap on the multicast is that you might be too late. So you either have to do it periodically or not. And I can refer to very interesting proposal from EVPN. It's a draft EVPN fast failover, and it will be going into the working group last call after the meeting at some time. They use BGP extension. So the BGP helps you to bootstrap point to multi-point BFD session. So it will be interesting to look when, and we'll look at control plane solution for beer. So if we can do the bootstrapping of BFD session.
But frankly, that's a function of the overlay, whatever the overlay is. We can't put it in line. We're transport.
No, it's not.
This is endpoint synchronization.
Yeah, but it's not. Again, it's not inline. It's basically you need to give information. So what would discriminator will be an identity of the head.
Whatever overlay will deal with it as a CP.
Yeah, it's a control plane. It could be control plane.
So the suggestion is that we should extend the IGP extension to bootstrap the BFD session. So I think this is maybe the one hop bootstrap.
We already have.
Who read the draft? Thinks this work belongs in the working group. I think we might have more than went up originally. So what the note says, we're nearly unanimous on the read comment. Yeah, thanks, Mike. Get that in. All right, appreciate it. We'll take that one to the list then. Great. Next up, 6-man in cap.
All right, so this hopefully is a discussion where people come to the mic pretty quick. I hijacked the presentation just a little bit last night. Jingrong presented this last IETF involving BRV6 encapsulation, involving the V6 destination option extension headers. There's a variety of ways to go about doing BRV6 encapsulation if we decide that that's the right way to do it. I know ICE has a draft out there that has been presented in the past involving putting the beer bit string into the destination address, the low order bits in the destination address, and high order bits for the unicast routing stuff. And so, and we look back at the mailing list to see some of the discussion that's happened with BRV6. And maybe you can set me straight on this. I haven't followed these discussions, but I kind of wanted to just have a discussion more on the next slide and the next few slides. And that is, should we be working on beer V6 in cap? And as according to the milestones, it's there. So it must, I'm guessing, be part of the charter. The chairs can correct us if we are wrong on that. And so if there is interest in working on this, I know V6 for beer is probably not a high priority for many of us. For us, it's getting higher just because we're working on our own implementations. We're discussing this with customers. We're trying to get them interested in beer. And V6 does come up. What is the strategy for beer V6? And so these are the kind of discussions that we're having. So, and then we need to determine if we really have a need for encapsulation that's V6 specific. So let me just pause there real quick to see if there's any comments up to this point. Because I'm hoping there's opinions, but maybe that's going to get the juices flowing for later.
Tony P. Juniper. So there's the effort to put it into link local to support the HomeNet Babel architecture.
There is that work, is that what you're saying?
Yeah,
Okay.
Beer in 6, the draft has been around for a bit. It's being implemented.
Okay.
So, Greg, as chair and from Cisco, right? So, thinking has evolved, right? And as Tony pointed out, there's work on Link Local V6 for INCAP. And I think what's important is articulating the use case so we understand there's a need to do something different. And the use case for link local V6 was like HomeNet, cheap boxes. Because ultimately, if you put something beer-like, beer bits into V6, it's not V6 anymore. The forwarding hop by hop still has to be beer. So you're kind of reappropriating an IP address for a different forwarding purpose. Kind of like what we did with V4 multicast in the first place, right? IP multicast is not IP. We created an abstraction with the address, but now we're putting reference into the address. And we're looking at hardware spin anyway to get that kind of support. And the hardware spin for extension headers in V6 would be a requirement as well. So I'm trying to understand what's unique about that use case when we, having specific beer header, we had the encapsulation discussion and the offsite interim working group meeting where we tried to, well, we accomplished a beer header consistency between native and cap and Ethernet, or excuse me, MPLS and cap. And we had cohesion, we moved forward. And so the V6 hop by hop fit into that space too. We didn't modify it. I'm not saying we don't need to find a way to do it, but I think we're at a maturity point, if I dare say maturity, where we need to better understand why this is different, why this use case is specific, that take the work we've done before and then modifying a header in some way and shoving it into somebody else's header, which now makes it neither V6 or beer, right? So if we can articulate that, then we can have a discussion about how we do it.
Who am between Nokia? Yeah, I think I second that. The beer forwarding is done via the beer index or the bets. And we need something to identify that this is a beer header. So I don't see why that identification has to be different in IPv4, IPv6. Like, to me, it's the same thing in both address family.
Okay.
And don't forget. Sorry?
Here, use this one.
Yeah, this one. And don't forget, I mean, we have already Ether and cap.
Yep.
Right, which serves lots of purposes.
Agreed. And we've discussed that previously. So I guess the question, and again, there's maybe not a big need to go into the details of this particular in-cap proposal because there's been a few of them, but is there a need, based upon your and Greg's comments, to have a problem statement draft that discusses the use cases of whether this is something that we need to pursue within this working group? Is that, we don't want to do it if it's not something that's necessary.
Sure, Greg is chair. I don't think we need a specific use case document for this, but I think there should be a use case section in this draft to better articulate what you're going after.
I see.
Yeah.
So, okay.
So for example, the HomeNet, it was simply that the chips, lots of chips cannot take a new MAC type easily, and they surely will not support beer for quite a time, right? So the only solution was going link local, very consciously, so you cannot easily go multiple hops, right? But if this has a use case section that shows cannot do that, fine. If it doesn't, well, we have a bunch of proposals on the table, right?
So you conclude use case to justify why we think that our solution is.
I do think so.
Yeah.
I do think so.
Yeah, that makes sense. Not to put ice on the block, but I will anyway. So your draft, is that, do you plan to continue to pursue that, the one that you've submitted a couple years ago, or? Oh, is it Pierre's draft? Okay. Just, that'll help us to know what to do.
Thanks for putting me on the spot. I was looking for a reason to come over anyway. So
You look scared, Ice.
He just woke up.
Yeah, it's a long week. Yeah. So the initial idea is, well, maybe I think the question is also, where do you want the beer processing to happen, right? So we defined the beer encoding, right? And then, and as Homan also said, like, you need a way to identify that header is following. You can have a label, right? We have an ether type, link local v6, different ways,
Protocol.
different ways to point to the beer header. And once you have the beer header, you can encapsulate anything below there, right? V4, V6, anything. So that's sort of need to figure out where the V6 angle comes in. Now, for the draft I'm on with with Pierre, we put the beer bits in the beer beer address. That also means that let's say the process that dealing with the v6 forwarding has access to the bits itself, and you can do beer specific processing inside your v6 code, right? So, and that made it so, let's say we did a hackathon at the time, right? I think we did the first hackathon that was done in IETF, and we prototyped that onto a Linux kernel. So it was quite easy to do because you have direct access to those bits because they're in the address. So that made it easier to get some beer forwarding going and not have like a generic beer forwarding code somewhere sitting in the kernel. So I think that was one of the attractions we had. So I haven't done much work recently on this. So we're not really sure yet what to do with the draft. And it's all depending on use cases, right? And problems we want to solve. So that's probably the big differentiation between our draft is, it's the v6 logic that can actually now look at the bits and do some beer logic themselves instead of having a generic beer forwarding to deal with it.
Okay.
Does that make any sense?
Yeah, it does. Yeah, and again, I know that it's not a high priority for all of us, but again, we just want to kind of get moving on it. So maybe what we'll do in our draft is, as we should anyway, we should highlight a specific use case, or we probably should reference other, maybe brief. I'm trying to decide whether our draft should be just specific to our NCAPs or if it should be more broad, to saying there's a variety of options you can do, whether you do want to do NCAP or not, or so that's what we got to kind of figure out. If someone's interested in kind of forming a new draft to kind of go over this, please let us know. Otherwise, we can just focus on ours. But that's kind of where we're at. Okay, thank you.
Just a semantic comment. After reading some of this and actually I gave a talk last night around this, and we keep saying NCAP, but there's actually two functions we're talking about here. There's encode and NCAP.
Yeah.
Right. So it's when we see this, and I've had talked to Cisco engineers who are v6 zealots who took 2 hours of wine and beer for them to realize if you're doing this to v6, it's not v6. And their whole hand was, let's put this in v6. So I don't know, put v6 on a pedestal or give beer a leg up with v6 connect or something. But to my point, once you do that, it's not v6 anymore. You're just kind of misappropriating the bits in some way. But I think in the use case for the draft that Pierre put together, the high order bit still had a v6 purpose. It wasn't like just taking the entire group. And the idea, it was questionable whether there was security issues with the six crew and whether that use case made sense. But he at least defined a use case where they were forwarding on the high order bits till they got to the beer domain and then blew up the bits down below on his beer.
Okay, that sounds good. How are we doing on time?
We can take this one more question.
I can just stand here, or
one more question.
There's a bunch of one more question.
I can stand here.
No, I really can. We have so just before you go, stay.
Because you're next anyway.
No, I'm not.
You're not.
Jingrong is, but so we encourage you to look at these other slides. We do have a slide on like kind of recapping some of the discussion that has happened on the list. Eric Rosen had a lot of good opinions on if we are to do something like a beer v6 in cap, then these are some things that we should consider. So we've got that, and we'll include that in our draft.
Stigvanas, so I have some specific comments, but I can give you those later. But I think what could be interesting might be to have an IPv4, IPv6 NCAP so that you can send a beer packet through, IP-only routers, basically bypass non-beer routers. But that's not what this draft is doing. I know, that's a different thing, I guess.
No.
Great idea.
No.
These guys don't like it, but okay. Any other comments? I guess maybe just my request from the chairs is if you can do maybe a raise of hands of who would be if this work is something that this working group thinks is interesting. Maybe not this specific work, but this whole topic of.
Who's read the draft? All right. Do you think there's potential to pick up this work in the working group? Raise your hand. Still kind of soft up and down. Again, my position is I need to better understand why we need something this specifically unique.
Okay. Well, in the next rev, we'll help make that more clear.
Cool.
Thank you.
Thanks, Mike. Next. segmented MBPMs. Oh, you have the power. There you go. You're in charge.
Good morning, everyone. I'm Jinrong from Huawei. Segmented mapping using IP lookup for beer. The draft has updated to its sixth version. Main part of this draft include some important terms, beer tallow, P2B tallow, and BGP mapping FEC. And one more term, pseudo VRF on segmented point. This is for IP lookup. Pseudo VRF is comparable to the BGP mapping FEC, represented by the root IP and the RD. The same concept is many beer tallows can share the same root IP and RD, and will be mapped to the same pseudo VRF. And generic concept is tallow sticking can be between any two of the MLDP, R3TE, or IR or beer tallow. And the end-to-end sticked tallow can be bound to one or many BGP mapping FEC from some ingress PE and VRF. And the ingress PE can decide to use which tallow for which flows. So here, possibly we use beer tallow bound to FEC and switch to the beer tallow bound to an FEC RD to special SG. But the IP lookup followed can ensure the replication optimized on the beer segment. So this is the IP lookup. This is the benefit of the IP lookup when many FEC bound to the same beer tallow. The pair tallow sticking of upstream tallow and downstream tallows and the pair flow IP lookup for downstream beer encapsulation are separated in this document. And the beer P2MP, P2MP beer all covered after in this update. Here we list the 3 comments we received. Comments 0. These comments came from Eric when I discussed with the authors of beer mapping before this 0 draft. And I found that the IP lookup exists in the 0.3.3 version of this draft and was lost in the fourth version draft. And also the main problem we want to solve, the multicast join latency, was added as more efficient in the mapping explicit tracking draft. So we agree with the text very much and think it was to leverage the more efficient tracking for beer in segmented deployment. Comment 1: Is this problem a beer specific or a more generic one? There is already defined RFC GTM using IR has very similar option to use a positive join leave AD from downstream, and the GTM using IR has a very similar option to use IP lookup when aggregating flows using one label. So this I think this draft is very similar to the proposal of positive join initiated by LIRPF and allow the aggregating flows using one label and the pair flow replication without flooding using IP lookup. The RFC has text on the about the IP lookup already, so authors think this draft is beer specific, and this draft is all about beer specific segmented VPN, how to leveraging the LIRPF and how to use IP lookup for pair flow forwarding on beer segment. Comment 2, how about other options for a better join latency? LIRPF can initiate the positive join of pair flow leaf-AD route and optimize the join latency. Pair flow VPN label allocation will require a round trip of SPMSI-AD and the ACT leaf-AD. And even worse, existing code may use a data-driven SPMSI-AD route advertising according to the RFC. And this can make the join latency even worse. And one option is to send the SPMSI route as soon as possible when being aware of any SG state. For example, when received a simulcast join, SG, or any form of source active information. And the other option is to use beer in an IPMSI manner, or we say in a flooding manner temporarily. So GTM using IR has such a special mechanism to get better join latency. And this can also be used by LIRPF explicit tracking. And comment 3, the positive and the negative of this proposal we list here. For IP lookup, VPN label can be lookup for the pseudo VRF, and again, the pseudo VRF and the customer source, customer group address lookup for a bit stream of the special flow. If we do without IP lookup, then we can look up the VPN label for bit stream directly, but this needs the allocating of VPN label for every safe flow before. From the forwarding cycles, IP lookup will need more forwarding cycles. Forwarding table rows and wide, IP lookup will need T plus N states. T represents the sticking talos and N represents the number of flows. T can be 1 in some case, and the N states is amphib or amphib 6. Of course, they are wider than the VPN label. And T is possibly can be N in some case. In such a case, of course, the IP lookup will cost more. So summary is IP lookup can help to leverage the more efficient LIRPF explicit tracking, and of course it has the cost, has the according cost. So this is the positive and the negative of this proposal. We believe this is stable after this update, and we want to ask for adoption poll. Also, welcome any comments. Thank you.
Jeffrey Zhang from Juniper. I replied on the email list saying that all the discussions still convince me more that this is not specific to beer. Except that the beer MVP draft said that do not use this explicit the LIRPF explicit tracking when you do the segmentation. Anything else is generic. It applies to any tunnel. That's my first point. The second point, so I love segmentation. There are scenarios where you do need segmentation, but every time when I bring up segmentation, customer says, that means I need to maintain states on the segmentation points. And now you're adding even more. You're adding the IP lookup, the verbs on those segmentation points. That will make it even less attractive.
Okay, thank you. The first question about this is beer specific or more generic. Yes, this draft only cover the beer specific part. We don't again include the more generic generic part. Do you mean this this draft must remove to must add more generic context and move to other working groups?
The draft could be written, at least written in ways that if beer didn't exist, this draft would still make sense. And it could be done that way. And whether it belongs to another working group, I think it should because it is generic, right?
But this draft only cover the main things we care about. That is the beer part, beer specific part.
Right. You in here you only care about beer, but
Yes.
We have a more generic problem to solve. We do not have to limit the scope to beer specifically. We can solve this problem that covers any tunnel type. Basically, if you need to do segmentation and you cannot do per flow label, then just do IP lookup. And whether it's beer tunnel or ingress replication, whatever.
Yes, but is this must to do things? I mean, I currently this draft only cover beer specific part, and you can have the separate draft to describe more generic topics.
Right. So that's what I'm going to ask. Tomorrow, if another tunnel comes, do you want to write a parallel draft?
Yeah, I don't want, but you can. Thank you. The second question. Okay, the second question about the forwarding states. I think this page has list all the from different view to list the positive and negative side. The so-called forwarding state is from the two view. One is the forwarding cycle, and one is from forwarding table rows and vice. I think and what we want to do to get the benefit is to leverage the more efficient LRPF explicit tracking. So the cost is also listed here.
Okay,
I guess
go.
the benefits to me, it's not worth the cost. That's my view, but we can have different views. Yeah.
Okay, yeah. This had cost.
Okay, Tony P, chair hat on. So for me, this is a beautiful example of a known use case, and I explain. We have a migration draft, right? And I think the intended progress is that we look at technologies that have stayed in the core and we try to migrate them into beer to save the state. That's the vision. This, in a sense, is putting more state back into the network, or even more state than previously, right? So you still have MLDP and have your beer on top. Of course, we can build any possible combinatorial of all the multicast technologies with beer, but I don't think this is something this group should, based on the charter and the original direction, attempt to do. So I would like to see that as a strong use case or as a migration scenario justification or something like that, because otherwise it's just removing MLDP to get beer in, to put MLDP in, to run beer over it. Okay.
Who's read the draft? Do you think this is work for this working group? All right, thin support. In fact, I think all the hands came down.
Yeah, I quickly read it. Gut feeling the amount
Name?
of state just answer abstract you put in place doesn't justify what you're trying to achieve. Just thinking from forwarding perspective, amount of state you would need to create and how you operate it and troubleshoot it when it breaks.
All right, any more comments? Anything outstanding? We have a few minutes. We can shout at each other if we want. It's usually the funnest part. I didn't expect to have time, so I didn't have any seated questions. Stig, did your issues get addressed yesterday? You were talking about possibly making some comments on
Stig Van As. So regarding the join signaling
yeah, I don't
draft-
remember specifically.
Okay. Yeah, there's one concern I had about the join signaling is that you only know who sent the join from looking at the beer header. And for PIM, once you've done the beer decap,
you lose that.
PIM doesn't really have any
Right.
context of what was in the beer header.
Okay.
So either you would have to have an implementation that somehow passes some data from the beer header up to PIM when you do the decap and pump the packet, or I think it would be easier to explicitly encode the sender's beef ID and stuff in the join itself, similar to what was done in MVPN.
Do you
The
expect
PTA.
it like a modification to the actual PIM join message itself?
One way would be to use a PIM join attribute.
Oh, okay. Okay.
Whom am I going to Nokia? Sorry, I missed the first part. Was this for the PIM signaling? Okay. So just to make sure, isn't the BFR ID of the IBBR in the beer header already?
Right.
Why
that's-
can't you just note that?
Yeah, my point is, if you look at the layers, you basically do the beer decap first, and then you punt the packet and PIM will process it, but then PIM doesn't have that context.
Why does PIM need that context?
Because you want to do explicit tracking, in order to know where you need to forward the data traffic later.
I don't know where the join came from.
That's part of the beer implementation table, which I think right off the bat we agreed that that's implementation. That's not a standard. There was a discussion about this right off the bat.
So basically, PIM needs to add an OIF, and that OIF needs to say something about where to forward a join. Or also, if you get a join and you add the OIF and you later get a prune, you need to know who that prune came from so you can update the state accordingly.
Okay, maybe we need to have this discussion about this, but the beer is where the OIF comes from, and it builds a table based on that, not anything to do with PIM itself. So you can note it like any other protocols out there and send it to PIM via whatever structure you want to use. But again, to me, this is implementation. This is not protocol.
Hi, Cisco. So remember that in BEER, there's also subdomains. So although you know the BFR ID that's in the packet, it doesn't tell you which subdomain you have to forward it on, right? Now, implicitly, that's encoded into the MPLS label, but it is a bit harder to figure it out because the label doesn't tell you anything, right? There's no context that comes with the label, so you have to look into BEER to figure that out. So from a design point of view, it's nicer if you can sort of maybe add it to the PIM join, just like what you do with BGP and the PTA. This is similar to doing that in PIM.
So that's fine. We can add the IBBR IP address as a source, I'm guessing. But then when you remove the BEER header, the extraction becomes an issue because we decided to send it as an IP protocol. We didn't come up with a brand new protocol for it. So you remove the BEER header, it's an IP protocol. What are you going to do now?
That's more or less my point, is that once you remove the BEER header, you lose that context about the source BFR ID and so on that you have in that header. So when PIM gets it, it's a pure IP packet. And then PIM needs some way of finding out what the source BFR ID was. So the easiest way is to put that in the joint packet itself. I should add, this is also an issue for the IGMP overlay. We may need some way of putting this in the IGMP packet.
Okay, again, we can have side discussions, but the implementation has been done, and like from our point of view, at least Nokia point of view, we had no issues whatsoever because we just built the OIF based on the information that you have.
Okay, so I'm curious how you did this. Does PIM have any state related to the OIF that says something about what BEER set to send a packet to, or is somehow all that state kept in somehow BEER itself, so that all PIM knows is that it should forward a packet to BEER?
So when the PIM packet goes into the PIM, I guess, stack, we do send the fact that the IBBR is this IP address, and that's it. That's all. I mean, when you grab this from the data path, whatever structure that you want to send out, because it's a control plane, you just send it out with the IBBR as a part of that structure, whatever the structure is. And when it goes to the PIM notes the fact that here's the IBBR and uses that IBBR as an OIF. Then we go to that table that we have with defining in the draft, and we just fill that table with the brand new OIF.
So you basically use the source of the PIM join to track the receivers and kind of represent which BFR the join came from.
And it's not only the source address, but also subdomain ID, that kind of thing. So in theory, you can use the incoming BEER label and the BEER header to figure out all that information. But indeed, typically when you send the packet up the stack, you remove headers one by one. So most likely maybe not the case in your implementation, but most likely when PIM gets the packet, all you have is just the PIM packet. So from protocol point of view, it will be good to have that additional information embedded in the PIM packets as Dick was suggesting.
So, to put it up back on architectural plan, there's nothing wrong with implementation like that. Right? It's your box, it's your vertical stack, you carry through whatever you need to get the job done. Architecturally, however, I think the limitation is then that your BGP and your PIM join and your BEER endpoint all have to be collocated, right? And do we accept this architectural limitation? I'm not making a suggestion forward, backwards, but it's surely not our mandate to determine how people implement the stuff. And it's a viable implementation within the architectural framework. Oh well, all bets are loose. That's what, people compete. But is that the wise architectural decision, I think, is what needs to be taken here
So again, I think the first draft that we gave out was trying to solve this issue by coming up with a new beer type, packet type that said, signaling. And then we were putting the IP address of the IBBR as a source IP. But it was said that that's not the right thing to do. So we went down the different path and
Right.
like not putting anybody on the spot. I think, Jeffrey, it was yourself that said, we need to not come up with a brand new protocol.
No, that's not the brand new protocol. Indeed, you just put the signal in the IP pack. That's all you need to do. At that time, that's what I think. And now, after Stig pointed out, I do realize that yes, your implementation could figure out that's all that's incoming prefix, a beer prefix, and the subdomain ID, or you could figure it out in your implementation by picking back up all those information. But a more easier way here would be to send that information along with in the PIM packet. So I changed my mind on this particular detail. But other than that, I still think it's good to send PIM join in its initial format, just with the beer encapsulation.
One more, then we got to cut it off. This is a conversation, but we are late.
Okay. I'm also happy with sending a PIM join directly over beer the way it is now.
Okay.
I just would like to have that information inside the join. But yeah, I would say when I wrote, the IGMP draft and implemented that, what I did was just use the source address of the IGMP,
Right.
Assume that's a beer prefix, and use that to find a beer for ID. And you can do that with PIM too. But the problem is you don't know the subdomain though. So I basically just use CLI to say, okay, any IGMP beer will be this subdomain, but it would be better if you could learn that from the IGMP report as well.
So work to be done. Who has the blue sheets? Blue sheets? Or everyone sign them? Anyone not sign? Right behind you, Jeffrey. Excellent. All right. Thank you guys very much. This is a
Yep.
wrap.
Yeah, that was excellent session.
Appreciate
Thanks
good
for the
conversation.
discussion. Yep.
We've got a lot to do in the list. Mike, send me the link to the minutes. Better yet, send them to Tony.
I don't even know what happened.
Nothing at Jabbers? All right. Cheers. It was not Jack.
Not